these are the exit tickets for Form C and Form D that you took in class today for bonus points back. We're going to go ahead and talk about Form C first, and then we'll look at Form D in just a moment. Form C says, students roll 2 identical 22-gram marbles off of the same 0.7 meter height lab table. Marble A leaves the horizontal tabletop with a velocity of 2.5 meters per second, becoming a projectile before landing on the floor below. Marble B rolls faster, leaving the table with twice the velocity, 5 meters per second. Assume no air resistance. One lab group produces the following graphs showing the horizontal and vertical displacement versus time for the slower marble A, 2.5 meters per second. So this is the XT graph for marble A. Again, and this is the YT or vertical displacement time graph. These graphs make sense for a projectile because this one shows a constant forward velocity, which is exactly what we would expect with any projectile. And for one that is a horizontal launch, which is basically what this is, rolling off of a lab table, we would expect that the vertical velocity starts out basically at 0 and then gets faster and faster, which is why our slope here gets steeper and steeper until it reaches a position of 0, meaning it's hit the ground. The height is 0. And so here it says, how would the horizontal XT graph compare for the faster marble? So if this is for the slower marble, how would it compare for the faster one? And what you would expect to see for the horizontal XT graph is that it would show a faster speed, because that's what this is. The slope of this XT graph is velocity. And so I would expect to see an XT graph with a slope that is steeper. Okay, and again, it would be twice as steep. I don't know if I drew that perfectly, but whatever. And so if you were comparing them, how would they compare? The XT graph would show a slope that was twice as steep. The slope of this one is 2.5, because it says so right here. The slope of this one would need to be 5. All right, as for the next question, how does the vertical graph compare? Vertical motion is independent of horizontal motion. So even though these leave at different speeds, okay, even though this one's leaving faster, vertically, the acceleration in the vertical direction is still 9.8 meters per second squared, which means, yes, this one's going to go farther, but it's still going to hit the ground in the same amount of time. And it still has the exact same vertical motion. All projectiles have the same vertical motion. All horizontally launched projectiles have the same vertical motion because they're all accelerating from rest at negative 9.8 meters per second squared. And because they both started at the same height, then the graph's going to be identical. So you're not going to have any change to the VT graph. They will be identical. Part C, how does the momentum of the slower marble A compare to the faster marble B just before impact with the ground? Again, these marbles have the same mass, but when they hit the ground, their velocities are different. Now, their vertical velocities are the same. Okay, so VF in the vertical direction is the same because they're both accelerating at the same rate. But VF in the X direction is obviously different because this one had a smaller Vx velocity to begin with. This one had a faster one to begin with. And so your first marble, this one is going to have a slower one, and the second marble is going to be faster. And because of that, because momentum is mass times velocity, and because these velocities are different, this one is going to be faster than this one. Then you're going to end up with different amounts of momentum because although the masses are the same, the velocities are not. And so your slower marble A will have less momentum than your faster marble B. It will have more momentum as a result. Form D is very similar. In fact, it's the exact same scenario. The difference is that we have different types of graphs. Here we're looking at velocity time graphs as opposed to position time graphs. So this one shows a constant velocity forward, which again is what you would see for every single VT graph for a horizontally launched projectile, or any projectile for that matter. My vertical velocity graph starts at 0 because, again, these are horizontal launches. They don't have initial vertical motion, and then it gets increasingly negative. It's getting faster in the negative direction, which makes sense. It's falling. And so this one says, how does the horizontal VXT graph, so this one, compare for the faster marble? So if this is the slower marbles graph, the faster marbles graph, it's still going to have a horizontal line. This one right here, my y-intercept is 2.5. So if I had another one, my y-intercept would have to be at 5 instead. So the line's still horizontal, but it's higher on the graph. And so I would have a different y-intercept, and so that would be the difference that exists, is that it would still show constant velocity. That's still a horizontal line, but my horizontal line has a different y-intercept. Instead of 2.5, this one would be at 5. Part B asks you to compare the vertical VT graph. And then again, vertical motion is independent of horizontal motion. The acceleration is still negative 9.8 meters per second squared for both. It doesn't matter that one of them was launched faster because the launch is horizontal. And so they still both start out, both of them have an initial velocity vertically of 0. And so both of them will have the same final vertical velocity at the end. They're both going to hit the ground at the same time. And those vertical VT graphs will be identical to each other. As for part C, this should say kinetic energy. Sorry. How does the kinetic energy of the slower marble compare to the faster marble? And it's pretty similar to what we talked about with the last one. Okay, I drew this picture before for the last problem because this is what we're looking at. This one is faster than this one. And when we look at the equation for kinetic energy, it's 1/2 mv squared. So although their masses are the same, their velocities are different. One of them is faster than the other one. Marble B is faster, therefore marble B is going to have greater kinetic energy at the end because, again, it hits the ground with a faster speed because it has more horizontal. The vertical part's the same, but the horizontal part means that its overall velocity is faster. And so you would say that your faster marble B has more kinetic energy than your slower marble A.